Hello everyone, welcome back to Algorithm with Chelsea. Today we will learn Python for loops with break. Break is a keyword that can stop a loop early. This is useful when we already got what we need, and we do not want to keep looping. Let's begin. Let's quickly review list traversal. Traverse means we visit each item in a list, one by one. In this example, numbers is a list containing 3, 1, 4. The loop says, for x in numbers, and then a colon. That means x becomes each item in the list, one at a time. So first x is 3, then x is 1, then x is 4. Inside the loop, we print x. Very important, the print line must be indented, usually 4 spaces. Indentation tells Python that this line is inside the loop, so it runs once for each item. Now let's learn break. Break exits the loop immediately. In the code, x goes through the list, 1, 2, 3, 4, 5. Inside the loop, we check if x double equals 3. When x becomes 3, we run break and the loop stops right away. Before we reveal the output, pause and predict what gets printed. Let's check. The output is 1, then 2. Here is why. When x is 1, the if condition is false, so we print 1. When x is 2, the if condition is still false, so we print 2. When x becomes 3, the if condition is true, so break runs. That stops the loop immediately. So we do not print 3, and we do not print anything after 3. Now we will search a list. We want to know if target is inside the list numbers. In this example, numbers contains 4, 7, 2, 9, 5. Target is 9. We want the program to tell us whether 9 is in the list. Here is the idea. We use a Boolean variable called found. A Boolean value is either true or false. We start with found equals false because we have not found the target yet. Then we traverse the list, item by item. If we see the target, we set found to true. After the loop finishes, we print found. Now let's walk through the code. We set found to false before the loop starts. Then the loop visits each x in numbers. If x double equals target, we set found to true. So when x becomes 9, the condition becomes true, and found becomes true. After the loop ends, we print found. Let's check the output. The output is true. That means the target is in the list. But notice something. Even after we find the target, the loop still checks the rest of the list. So it works, but it may do lots of unnecessary work. Here is another example. The only difference is target. Previously, target was 9. Now target is 4, the first item. We find it on the first iteration. But the loop still keeps checking the rest of the items, 7, 2, 9, 5. That extra work is not needed because we already know the answer is true. So we can use break to stop as soon as we find the target. Now we add break. When we find the target, we do 2 things. First, set found to true. Second, run break to stop the loop immediately. So if the target is near the front, we stop early and save time. The output is still true. So we get the same correct answer, but we can finish faster. Suppose numbers has 1 million items. If the target is near the front, break can stop the loop very early. That saves a lot of work. Same answer, but faster. Now, question 1. Stop early. Numbers contains 2, 7, 8, 5, 8, 9. We loop through x in numbers. If x double equals 8, we break. Otherwise, we print x. What is the output? Pause and predict the lines. Let's check. The output is 2, then 7. Because the loop prints 2, prints 7, then x becomes 8. When x becomes 8, break runs, and the loop stops. Now we will search a list of student names. Students is a list containing Ava, Ben, Cody, Dina. If target is in the list, print its index. If target is not found, print -1. Here is the idea. Start with result equals -1. -1 means not found. Let n be the length of the students list. Then, we loop over index I using range n. So I goes from 0 to n-1. If students at index I equals target, we set result to I, and then break. Finally, print result. Let's walk through the Python code. The inputs are a list of student names, and the target, Cody. Result starts with -1. N is the length of the list, students. There are 4 students, so n is 4. Loop I in range n. I will be 0, 1, 2, 3. When I is 0, the list item is Ava, not Cody. When I is 1, the list item is Ben, not Cody. When I is 2, the list item is Cody. We found the target. So we set result to 2, then break to stop early. Then we print result. The output is 2. That means Cody is at index 2 in the list. Now target is Chelsea. We still start with result equals -1. The loop checks Ava, Ben, Cody, and Dina. None matches Chelsea, so result never changes. So we print -1 at the end. The output is -1. That means the target name is not in the list. Now question 2. List students is the same. Target is Cody. This loop prints the student name first, and then checks if it is the target. If it is the target, the loop breaks. What is the output? Pause and answer. Let's check. The output is Ava, then Ben, then Cody. Dina does not print, because the loop breaks right after printing Cody. Python also allows negative indices. Index -1 means the last item in the list. Index -2 means the second to last item in the list. In the example list 10, 20, 30, 40, the last item is 40, so index -1 gives 40. The second to last item is 30, so index -2 gives 30. Now we will use break in a Fibonacci example. The Fibonacci numbers start like this: 1, 1, 2, 3, 5, 8, 13, and so on. Each number is the sum of the previous 2 numbers. For example, 2 is 1 plus 1, and 3 is 1 plus 2. Goal: build a list of Fibonacci numbers that are less than or equal to 100. Here is the idea. Start with a list named fib containing 1 and 1. The next Fibonacci number is the sum of the last 2 items in fib. If the next number is greater than 100, we stop the loop using break. Otherwise, we append the next number to the list. We do not know how many Fibonacci numbers are under 100, so we use a very large loop, like 1,000 times, and we rely on break to stop early. Now let's read the code. Fib starts as 1, 1. We loop for underscore in range 1,000. Underscore is a common name when we do not plan to use the loop variable. In each loop, we compute next as the sum of the last 2 Fibonacci numbers. If next is greater than 100, we break. If not, we append next to the end of the list fib. At the end, we print the fib list to see what we collected. Let's check the output. The list is 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. The next Fibonacci number would be 144, which is greater than 100. So we stop before adding it. Now, question 3. We moved append earlier. Now the code appends next first, and only then checks if next is greater than 100. So a number greater than 100 might get added before the loop breaks. What is the output now? Pause and think carefully. Let's check. Now the printed list ends with 144. It is greater than 100. Why printing 144? Because we append 144 before we check if it is greater than 100. After printing, we check the condition and realize 144 is greater than 100, and thus break stop the loop. Let's summarize what we learned today. Break stops a loop immediately. Use break to stop early so your program can run faster. For searching, once we find the target, we can break instead of checking the rest. Negative indices. Index -1 is the last item. Index -2 is the second to last item. Fibonacci numbers. The next number is the sum of the last two numbers, and break helps us stop at the right time. This concludes our lecture. Thank you for watching. Please subscribe to Algorithm with Chelsea so you won't miss future updates.